So today we are discussing about the we have used considered the notation of the let us consider this lemma. What is this lemma says? Yeah, that we will write here. കൊണ്ടുവന്നോ ജേഴ്സി ജേഴ്സി കൊണ്ടുവന്നോ എനിക്കല്ല ബുക്ക് കൊണ്ടുവന്നോ മാർക്കല്ല ഇനി പോകുമ്പോ എന്നാ ഐജോനെ വിളിച്ചേ ഐജോ equal to phi of x, that is the structure function of the system. That is equal to xi into phi of 1i comma x plus 1 minus xi into phi of 0 comma x. Xi എന്തായാലും പോയിട്ട് വാ ജയ്സ ജയ്സ
ഞാൻ ക്ലാസ്
അല്ല പറഞ്ഞോ ഐജനോട് xi okay ഏതെങ്കിലും ഇട്ടൂടെ ഓക്കെ 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 ഓഫ് what is this? This is a representation of the structure function. This means phi of x comma 1i means what is that? The component I is restricted to 1 and phi x comma 0i means the component I is restricted into field set 0. Okay, so there are two possibilities, that is xi can be 1 or xi can be 0. So let us look at look the special case, that is what will be the right side of this function? What will be the right side? Suppose xi equal to 1. Suppose we are suppose it's xi equal to 1, then what will be the it will be 1 and it will be 1. So the result will be, what will be the result? Just phi of x comma 1i. Okay, 1i when xi equal to 1. What happens when xi equal to 0? What will be the representation when xi equal to 0? Yeah, it will be 0 and it will be 0. Okay, so the only this part is appearing 0. So we can phi of x equal to phi of xi comma 1i if xi equal to 1, and phi of x comma 0i when xi equal to 0. So this equation 2 and equation 3 is simultaneously represented here. Okay, otherwise we get equation 2 and equation 3 from 1. So this is a general representation of this equation 2 and equation 3. So that is proved here as a lemma. Okay, let us leave this part. Here we have an example, and another concept is another definition is dual. I think this concept is dual concept. What is dual? Dual of a structure function. We can define dual of a structure function like this. Phi d. What is phi d? Yeah, phi raised to d. That is dual. Phi raised to d of x equal to, that is exactly 1 minus phi of 1 minus x. This is the dual formula. Okay, what is dual formula? Phi d of x equal to 1 minus phi of 1 minus x. Okay, so that is the if this is the structure function of a system, then it is the structure function of a dual system. So let us look at two examples. Suppose we are considering that series system. Then what will be the dual of the system? If phi of x, if phi is a series system, we know that if series system is considered, then what will be the structure function? Yeah, structure function will be phi of x equal to product I from 1 to n, phi of x will be, what is that? Yeah, it will be some product I from 1 to n xi. Okay, xi, that is the structure function of a series system. So suppose that we are considering series system, then phi of x will be like this. So what will be this one? Yeah, instead of xi we use 1 minus xi. So we can substitute this and we can replace with 1 minus xi. Okay, we have replaced phi of 1 minus x with the product I from 1 to n, 1 minus xi. This is exactly structure function of parallel system. Okay. Okay. This is exactly equal to the structure function of parallel system. Okay. Now we consider what is that? Structure function of a, if the system is if parallel system is considered, what happens? If parallel system is considered, then phi of this one will be 1 minus what is this? 1 minus. Okay, this is the structure function of the PAL system. So what will be the representation of dual structure? What will be the representation of dual structure? Yeah, we can substitute this result in the right side. We can see that. So instead of xi we have to use 1 minus xi. So just substitute first and then replace xi with the 1 minus xi. So this is the general common minus. Okay. So what happens? As a result, you will get this is equal to 1 and 1 will get cancelled. Negative and negative become positive. Then the remaining term is product. Okay. Product I from 1 to n. What is that? 1 and 1 get cancelled. If this 1 and 1 get cancelled, only just xi remains there. Okay. So this is the structure function of the series system structure. So these are the examples. So this is the definition of dual structure. Phi d of x equal 1 minus phi of 1 minus x. The example is series system. The series system is the dual of parallel system. Parallel system is the dual of series system. Similarly, we can find out the dual of any system. Okay, that is the usual procedure. Now we consider coherent system. So what type of systems are called coherent system? Yeah, a system is said to be coherent if all the components are relevant and phi is increasing. What is when we increasing? Yeah, I will show that. Increasing means phi increasing. Let us take the print screen and I will send you this dual concept to your WhatsApp group. Okay, it is not available now. Anyway, we will send, no problem. So now we move to coherent system. What are the specialties of coherent system? One is all the components are relevant. Second condition is phi is structure function. Is increasing. Okay. So what is when we increasing or relevant? Relevant we have discussed. What is when we increasing? You know the concept of increasing. When we say that a function is increasing, yeah, the situation is that is phi of increasing means phi of x comma 0i less than or equal to phi of x comma 1i. So this is situation we call increasing. Strictly increasing means equal to part will not be appear. Increasing means less than or equal to. If it is strictly increasing, only less than sign appears. So this is the two minimal conditions required for a system to be coherent. So a system is called coherent if all the components are relevant and the structure function is increasing. So that are the two conditions. Okay. So you got the idea of structure relevancy. Yeah, examples are series system and parallel system are coherent systems. Yeah, here they have given number of coherent system structures. two component series system, two component parallel system, three component series, three component parallel, series parallel, parallel series, etc. These are all relevant. You can check from your home. Okay. Now we move to a theorem, that is very important theorem, usually appear in examination. Phi be a coherent structure function of component. Then what is the theorem? Statement of the theorem. Yeah, if a system is coherent, then the theorem says that product I from 1 to n. Product I from 1 to n. Product I equal to 1 to n xi. Okay. Let us denote with the small letter, no problem. Okay. That is less than or equal to phi of vector x. Vector x means capital X we denote, or we can put a vector mark here. Okay, we put vector x means x1, x2, etc. Okay, you can use any of the notation. Yes. Vector x means x1, x2, x3, xn. That is less than or equal to what is that? Union. You know what is the meaning of union? I equal to 1 to n xi. So this condition satisfies for every coherent system. So that is the theorem statement. So we can prove the theorem by using, you know that all the xi satisfy. What is the values of xi? Xi's are xi equal to 0 or 1. There are two possibilities for xi, that are either 0 or 1. What are the values of I? 1, 2, etc. That is the component number. That is actually the component number. So the component states are 0 or 1. Suppose that, understand, we are assuming that all xi's are 0. Okay. All xi's are 0. Assuming only the
പെൻ നമ്പറില്ലാത്ത സെൽഫ് ഫിനാൻസിൽ അവരെന്ത് ചെയ്യുന്നത്?
ഐ ഡി കാർഡിൻ്റെ നമ്പർ,
അവർ ഐ ഡി കാർഡിൽ നമ്പർ കോട്ടയപ്പം.
So as you, assume x equal to 0 for I equal to 1, then what happens? Yeah, product will be 0 and phi of x will be 0 and the union also will be 0. Okay, now we assume that all xi's are 1, then what happens? Product will be 1, phi of x will be 1 functioning, union parallel system will be functioning. Okay, but we have another situation, that is here we have mentioned if product xi equal to 1. Another situation, that is suppose that product xi equal to 1. Okay, product xi equal to 1, then automatically the higher value will be 1 and this will be also 1. That happens when all xi's are 1. Okay, when all xi's are 1, product xi 1, automatically phi of x will be 1. So there is no confusion with for the left side. Okay, and suppose that sum x's are 1, some x's are 1, okay, that means some x's are 0, some other x's are 0. Okay, there. പറഞ്ഞോ. ഉണ്ട് ഇത് പോരട്ടോ. ഡിഫറെൻ്റ് ആയത് എടുക്കടാ, പെട്ടെന്ന് എടുക്കടാ. അറിയാൻ പോല എനിക്കറിയില്ല, എൻ്റെ ഞങ്ങൾക്ക് കിട്ടിയില്ല കേട്ടോ. ടിക്കറ്റ് കൊണ്ടുവന്നില്ല. തൽക്കാലം ഇന്ന് പരീക്ഷ എഴുതി പേപ്പർ എടുത്ത് റിക്വസ്റ്റ് എഴുതിട്ട് ഇന്നലെ വന്ന ആളായതുകൊണ്ട്. അല്ല ഇന്നലെ വന്നല്ലേ?
അപ്പൊ ഇന്നലെ ഉണ്ടായിരുന്നില്ലേ ഹോൾ ടിക്കറ്റ്? അപ്പൊ ഇന്ന് എവിടേക്ക് പോയി?
So if some x's are 1, then some other x's are will be 0. So in that case product xi will be 0, but at the same time phi of x can be 1. For example, in radio system we have discussed yesterday, there are possibility for product അങ്ങനെ പലതും പറയും. So some x's are 1 and some other x's are 0. Okay, then what happens? ഞാനൊരു 10 മിനിറ്റ് കഴിഞ്ഞിട്ട് പറയാം. ഇല്ലല്ലേ? അല്ല ഞാൻ ക്ലാസ്സിലാണ്. ഓക്കെ അപ്പോൾ 10 മിനിറ്റ്. So some other x's will be 0. Then the coherent system may be working. For example, in the yesterday's discussion we have a radio system. If the changer is failed and speaker 1 is failed, then also the system is functioning. So but if we consider series system, if we consider as a series system, radio system as a series system, then we must have product xi equal to 0. So radio system coherent system, and even though 1 or 2 components are failed, the radio system will be working. For example, if a changer is failed situation and if speaker 1 is in this failed situation, then still the system is functioning. So if any one of the components are in failed state, the coherent system may be in functioning state. But at the same time, series system will be, if any one of these components are in failed state, the series system will be in failed state. So we will have product xi equal to 0 in this case. At the same time, phi of x may be 0 or may be 1. Okay, so there are two situations. That is, in this case, product is always 0. Product is always 0. In this case, we have, that means product is always 0. At the same time, phi of x can be 0 or 1. Phi of x equal to 0 or 1. Two possibilities are there in this case. So we can ensure that this less than or equal to inequality holds. Okay. When sum of xi's are 0 and sum of xi's are 1, product will be 0. At the same time, coherent system may be in functioning status or in failed state. For example, if amplifier is failed in the radio system, the coherent system, radio system will be in failed state. If speaker 1 is only one component with failed status in the radio system, then the radio system will be in functioning status. So there is a possibility for 1. So we can ensure this less than or equal to inequality. Another situation is, suppose that union xi equal to 0. Suppose that union xi equal to 0. What is actually union? You know the union. Yes, put that. Suppose our union xi equal to 0. Then what is it means? This is equal to 1 minus equal to 0. So if this is equal to 0, we can ensure that this is equal to 1. The product will be 1 if and only if all xi's are 0. Product will be 1. This is possible only when product will be 1 when 1 minus xi equal to 1. This is possible only when all xi's are 0. All xi's are 0. When all xi's are 0, phi of x will be 0. When all x's are 0, phi of x will be 0. So we can ensure that when this is equal to 0, then phi of x is automatically equal to 0. Now we consider another situation, that is product is union is 1. What happens? Let us look at that. When union equal to 1, then union 1 means this will be 1. Okay, 1 minus product I from 1 and 1 minus xi 1. That means it will be 0. It will be 0 when this is 0 for some I. Not for all I. For some I, 1 minus xi equal to 0. So that means for some I, xi equal to 1. Okay. That means if some I for some I x's are 1, then there is a possibility for 0 as well as 1. For example, when in radius system, suppose that x2, x3 and x4 are 1, then certainly phi of x is 1. And for another example, suppose that in radius system x1 is 1, x2 is 1, at the same time x4 is 1, x1, x2, x4. So the amplifier will be in failed state. So in the radius system we cannot ensure the functioning of the radius system. So if x2, x3, x4 is in a functioning state, the radius system will be functioning. On the other hand, if x1, x2 and x4 are in functioning state and x3 and x5 are in failed state, then phi of x will be 0. So there are two possibilities. So when product union xi equal to 1, there are two possibilities for phi of x, that is it can be 0 or 1. The example is radius system. That is the reason for discussing yesterday radius system. Each and every components we have discussed, written in your notebook. Okay, so this can be ensured. ആറ് സെറ്റ് ഉണ്ട് നോക്കണം, അതിൻ്റെ ഇതുണ്ടാവില്ല 15 ബിക്ക് 15 മിനിറ്റ് ഉണ്ടാവില്ല അല്ലേ? 17 പേപ്പറാണോ? 17 പേപ്പറിലോ
core course BBA marketing management for BBA
സെയിം പേപ്പർ
ഇല്ല സെയിം പേപ്പർ ഒന്നും ഉദ്ദേശിക്കാൻ കാരണം ഇതുവരെയായിരുന്നു BBA
ഇന്നലെ അപ്പോൾ കൺഫ്യൂഷൻ വന്നു. 2 പേപ്പർ വന്നു.
മാർക്കറ്റിംഗ് മാനേജ്മെന്റ് 15 ഓൺ പാസ് നടക്കും. ഇത് എഴുതിയേക്കുന്നത് റെഗുലറിലാണ്. SD ഒന്നും എഴുതിയില്ല, ഒരെണ്ണം എഴുതിയിട്ടുള്ള ബികോം
ഉണ്ട്.
പിന്നെ വീണ്ടും പുതിയ
വൊക്കേഷനുണ്ട്.
വൊക്കേഷനുണ്ട് ഈ മറ്റേ ഓണം.
So how you got the idea? This is actually this two sentence. We have discussed this two sentence in detail using this word. I will send it to you in your WhatsApp group, no problem. Desktop. If you have any doubt, you can ask to me. ഇതെന്തായിരുന്നു? Coherent എന്ന് എഴുതാം. Okay. Reliability we have saved that. So this is the So we can ensure, yeah, the conclusion is we can ensure this inequality. At first we have ensured this inequality using the above step. Using the below step we have ensured this inequality. Okay. So actually okay. That means when union xi equal to 1, phi of x can be 0 or 1. And on the other hand, we can yeah, we have discussed the two situations, when union equal to 0 and union equal to 1. Okay. I think this is sufficient for understanding that theorem.